Hello and welcome again to Heybridge Maths Department. We're looking at Year 2 Pure, Chapter 5 Radians, and we're carrying on with the first section on radians. We're doing the second part of that first section, so subpart of a chapter, and we're going to be looking at exact values, and we're also going to look at the graphs of trig functions. So exact values of trig functions, I should say, and the graphs of trig functions when we're measuring the angle in radians. So if we're measuring the angle in radians, what does the graph look like? What are the exact values for certain trig angles when we're in radians? That's what we're going to look at today. Right, so let's get started here with, first of all, we've got some common conversions here between angles and degrees, ones that we will see regularly. So you will see that 30 degrees is pi over 6 radians. We could go through the laborious task of converting it from degrees to radians like we did in the last video, or you can learn the fact that 30 degrees is the same as pi over 6. 90 degrees is the same as pi over 2. 360 degrees is the same as 2 pi. What I suggest you do is you get an Anki deck. I'm all about Anki these days. Get a deck for trig values, make yourself one, and just memorize them, and it'll take you no time at all. You're not talking very long to commit those values to long-term memory. And also, it would be a good idea to commit these to memory here. These here, you can see the pen there, just doing the rounds. These here are exact trig values. So you know that sine 30 is a half. So therefore, if 30 is pi over 6, then sine pi over 6 is a half. And you know that tan 45 is 1. So if you know that 45 degrees is the same as pi over 4, then tan of pi over 4 is 1. So we get these exact values here for trig functions here. So what I'd like you to do is, with that Anki deck that you've created to convert these ones here, these common ones, with that Anki deck, I also want you to stick in these here, and I want you to memorize them. There's not much to memorize in math. It's not like French where you've got a million and one pieces of vocabulary to learn and verbs to decline. There's none of that in maths. There's just a few little things to learn, but this is one of those times. And when it comes to one of those times, you need some way of easily remembering it. And for me, that's all about using Anki. Right, okay. So a couple of, I hope, very straightforward questions coming up here. What I want you to do is simply, in your calculator, type in sine of 0.3, making sure you have changed the mode of your calculator to radians. So make sure you've changed your calculator into radians. You've taken it off degrees. You should get up in the little top corner, little r. And if you've got that little r, then if you change the sine, so you've got sine, so you've changed it, sorry, into radians, and then if you type in sine of 0.3 into your calculator, you get something that is approximately 0.3. And if you do cos of pi and you type that in your calculator, well, we know that pi is the same as 180 degrees, and cos of 180, if you remember, is -1. So cos of pi would, of course, be exactly -1. Okay, so two very straightforward questions there for you. What I want you to do, copy those down and then have a go at this. I'm going to assume that you've paused at some point throughout that pause, and you should have had a go at this. And if you did, you got that tan 2 equals minus 2.19. Okay. Right, I hope that's relatively straightforward, but we can use the fact that we've got these exact values. We can use our calculator, and if we were so inclined, we could laboriously calculate a table of values and draw out our trig values. So we could do for each small little change in value of x, we could plot a new point of sine x or cos x and tan x and work it all out. We're not going to do that. That's too much effort. But I do want you to think back to your graphs of sine, cos, and tan, and think how that's going to relate. So my first question here is, we want to draw the graph of y equals sine x. And this is going between 0 and 2 pi. Now, if you remember, 2 pi is the equivalent to 360, because there's 360 degrees in a circle and there's 2 pi radians in a circle. So we want to draw the graph of sine x. So we know, and I'm going to do this very roughly, we know that the graph is going to look something like that, because that's what it looks like between 0 and 360. We know that that's 180, so we know that will be pi. We know that that's going to be 2 pi. That's going to be, this point here is going to be halfway between pi and 2 pi, which is 1.5 pi or 3 over 2 pi, and it's going to be at -1. Here, it's going to be pi over 2, because here's 0, here's pi, halfway in between is going to be pi over 2. Can't really tell much from my graph, but that is supposed to be symmetrical. And then at the top here, we've got 1. So that's supposed to be a 1. That's pi over 2. But if you want to see a much neater, much better version, in true Blue Peter fashion, I'm going to do it like I'm a presenter on Blue Peter. Here's one I made earlier. So there you go. Copy that down. Don't copy my horrendous graph. Copy a sketch of that version there of y equals sine x. And then what I'd like you to do is, once you've got this copied down, you might want to pause it now, copy it down, and then have a go at these questions here. So what I want you to do is, I want you to sketch these 3 graphs for me. Now, you are going to have to combine your knowledge of trig graphs, your knowledge of transformations, and your knowledge of radians. So you're bringing together 3 different areas of maths all into one topic here, but you're going to need to bring them all together so that you can solve them. What I would do is, I would, in question 1, start off with a graph of tan x in radian form. Think what that would look like. Then, once you've sorted with that, think what 2x would do, tan of 2x would do to the graph in terms of graph transformations, and then you're there. Likewise, in question 2, work out what the graph of cos x is going to look like in radian form, and then think what +1 does in terms of transformations, and then enact that transformation. Likewise, in question 3, you've got 2 transformations going on there. There's a bit more going on, so have a go at that, and then we will talk in a minute. Okay, so off you go with those 3 questions there, please. Okay, I'm going to assume that you paused at some point, and this is like ages later when you've had a go at doing these, and now I'm going to, not a few seconds later, but ages later, I'm going to go through these questions here. Right, okay, so first of all, as I said, sketch out the graph of tan x. And this is what tan x looks like when we're talking about radians. If you look back at the example above, it says between 0 and 2 pi. So we've gone a little bit past 0, we've gone into the negatives here, and we've gone a little bit past here. But here, between 0 and 2 pi is what we want to learn. The fact that it's pi over 4 that's going to give us a value of 1. It's going to be pi over 2. This is an asymptote here. We could even draw on the asymptote here to make it clear that there's whoa, it's a slanted asymptote. That should be going through pi over 2. Likewise here, yeah, actually, can I just delete that? Because it would make more sense to actually have it going on the straight line there. So if we've got that there, let's put it on that line, because that's where pi over 2 is going to be. So there's pi over 2. Here's 3 pi over 2. So it's going to look like that. You've got the asymptote there. You've got it going through 1 at pi over 4 and 5 pi over 4. And it looks like that. But now we want to do tan of 2x. Now, 2x is going to be a stretch in the x direction because it's inside the bracket. You're doing the 2x first before you're taking the tan of it. So you're doing the 2x first. So it's in the x direction, but it does the opposite of what you want to do. Remember the lion story. Remember that lion. He's in the cage. He's in that bracket cage. So he does what you, and he's lying down because he's in that cage. He's lying down. He's in that cage, and he does the opposite. So you want him to stretch out. What does he do? He crawls up. So he does the opposite of what you want to do. So it's a stretch of a scale factor of half. So you get something that looks like that. Excellent. Right. That's what it does. It pushes it all in by a scale factor. Well, it stretches it by a scale factor of half. I guess it pushes it in. Not pushes it in is the correct mathematical term, and you can't use that in an exam. But it pushes it in by a factor of 2. So we call it a stretch of a half, and you get something that looks like that. Okay, now let's move on to number 2. In number 2, we are going to do, let's just take it back up to here, cos x plus 1. So we need to sketch out the graph of cos x. And if you did that, you get something that looks like that. Again, you've got pi over 2 here, this dot here, 3 pi over 2 here. No asymptotes for me to mess up this time, but you can see the general shape of the graph here. You can see the pi, the 2 pi. You have to be quick at swapping between degrees and radians. Well, you need to sort of just be thinking in radians eventually. But you get a graph that looks like that. Now, if we're going to do cos x plus 1, this time the line is out of his cage because it's plus 1, it's outside. So he's jumping up into the air and he's going by 1 unit. He's jumping up by 1 unit. He's out of a cage. So he jumps up by 1 unit. So it's going to go up like that. He's going up by 1. It's a translation in the y direction by 1 unit. Or you can say translation parallel to the y-axis by 1 unit. You can't say a translation in the y-axis by 1 unit. You can't mix up the two. But if you say a translation in the y direction by 1 unit, that would get you the marks in an exam. Right, and the last one, where we are going to do 2 transformations here. We're going to do the sine 2x plus pi over 2. So we are going to do a stretch in the x direction, scale factor of half, and then we're going to translate by pi over 2 so that we get something that looks like there's sine x. We've seen that one before. Now, if we look at sine 2x, we get something like that. So it's a stretch in the x direction, scale factor of half. We've seen that before. And then once we've done that, what we've got to do is translate it, not where you'd want it to go. It does the opposite of what you want it to do, translates by pi over 2, but going the opposite way to the way that you want it to go. So you think, oh, do you know what? I want it to go to the right, because that's what you'd think, adding on pi over 2. But the lion is in the cage and he does the opposite of what you want him to do. He goes pi over 2 in the other direction. He shifts to the left. So you get a graph that looks like that. Then let's move on to something just slightly bit esoteric to finish off with. Yeah, there's your graph of sine x plus pi over 2. And finally, let's have a look at working out some exact values when we're not when we're not looking at principal values, when we're looking outside of pi over naught and pi over 2. When we're looking at that, what do we get here? So if we're looking at cos 4 pi over 3, then if we think of the graph of cos, here's the graph of cos 4 pi over 3. Well, that's going to be, well, here's pi here, where the symmetry is. So there's pi. And of course, that makes that working trig values. 4 pi over 3 is just going to be a little bit past there. So there's 4 pi over 3. And we want to work out this. Now, this value here, what's it the same as when we think about principal values? So what is it over here when it's between there? Well, if you look at the beautiful symmetry of a cos curve, then you will see that this value here will be the negative of this one here. So this is going to be pi over 3. And if you think of cos of pi over 3, that's cos of 60, which is a half. So this value here is going to be minus a half. So cos 4 pi over 3 is the same as minus cos of pi over 3, which equals minus a half. Okay, and then what I'd like you to do is think about the graph, think about principal values, think about symmetry, and see if you can work out the exact value of sine of minus 7 pi over 6. Right, okay, so hopefully you've paused, had a go at this by now. Then if we think about the graph of sine, let's take it all the way into the negatives. Let's think about the negatives. Let's think here's my beautiful sine curve with this value here being pi. Here's minus pi here. Now, what we want here is minus 7 pi over 6, which is this point here. And what we're looking at is what this value is here. Now, looking at the symmetry here, if you've got minus pi here and minus 7 pi over 6 here, you've gone pi over 6 past the curve there. So that is going to be the same as this distance here. This distance and this distance are the same. So that's going to be pi over 6. And then you've got sine of minus 7 pi over 6, which is the same as sine of pi over 6, which you know equals 1/2. Okay, and that's where we're going to leave it for now. If you haven't done all of exercise 5A, please complete that. And then could you have a go at exercise 5B for me, please, and answer the questions on that, please. Thank you very much. Goodbye.